Hello everybody, I'm gonna talk today about recent research between medicine, computer science, and statistics and sonification. Sonification clustering, a multi-sensory perspective for precision medicine. This is a joint research with Dr. Veronica Distefano. Amongst the complications of type 2 diabetes, there is the diabetic kidney disease, in short DKD. This is a very serious illness characterized by the reduction of kidney filtering efficiency. Values of kidney efficiency are mainly measured by eGFR, where E stands for estimated out of different variables, and glomerular refers to the glomeruli, these small sections inside human kidneys. The threshold value is this one. Values of eGFR below 60 characterize damage, a reduction in kidney efficiency. Values below 15 milliliters per minute, 1.73 meters per second, indicate kidney failure. The correction eGFR values over time are trajectories. We have for each patient a collection of 4 values that we can map into pitches, obtaining melodies. And this way we can listen to data and collect information. Comparing melodies, we compare patients' eGFR time evolution across time, which is particularly helpful in finding similarities of behavior based on similarities of melodies. This is our strategy. We start from original data, we sonify them, getting the sonified data. Then we apply the same clustering technique to both topologies of data, looking for similarity and differences, which may highlight the possible advantages of the sonification strategy. A former study was about trajectory-based, sound-based medical data clustering, where we only considered 10 patients, and we based our clustering on Frechet distance. These are some examples of the auditory superpositions we get. And this other one. Here we are considering the try method, which uses 24 different measures characterize each one of the time series. This is a method proposed by Lefondre and co-authors. In our dataset, there are 256 DKD patients. This is our sonification strategy. We start from eGFR values, we rescale them, and then we map them into hertz. We also have a step of discretization to work with Western musical notes. Each eGFR value is giving thus a fundamental pitch. We also consider timbre in the sense that the younger the patient, the brighter the patient, the brighter the sound. We obtain that by using an inverse mapping from age to spectral centroid. In the following examples, we first of all focus on the fundamental pitches rather than on centroid changes. So this is how the first patient is sounding like. The trajectory of the second one is. And for the third one, if we try to modify the timbre, we can focus not only on the spectral centroid, but also on the shape, the overall shape of the spectrum. The red arrows are indicating approximately the position of the centroid. The second one. And the third one. We obtain the sound with values and modify them with Melodyne. So let us now consider an example superposition of melodies. Let us first hear the melody from data of patient A, which is not the first patient in the database, but is one of 3 randomly selected patients. The second one, and the third one. The 3 of them together. We notice from our analysis that patients A and B are in the same cluster. This is one of the melodies we have. When we try to modify both centroid and spectrum, we obtain, for example, this result, trying to match the centroid to the one obtained through the age. These are our results. So, considering the clusters of original values, we notice a switch between mean trajectories of EGFR for patients. This can be justified by the clinical characterization of the patient, and which are leading to a worsening of the kidney filtering function. On the right, we have the graphs of the mean curves obtained for the sonified values. Patients in cluster 3 of sonified values are showing a very different shape. We also notice that most of the patients changed the drug, had a different drug after the first follow-up, which is time 2 in this dataset. And the sonified data are highlighting this information, the effect of drug change for some of the patients. Another clustering strategy is powered by the Fourier analysis applied to symbolic music content. We still obtain sonified data in the same way, but we obtain the Fourier coefficients and we cluster patients according to this information. This is the formula where we have 4-note melodies and coefficients for times from 1 to 4. Then we obtain a possible cluster distribution, which in 6 cases out of 10 is giving the same result of the try method. Next steps, we are about sonification and clustering of non-discretized values, and we will be running more tests with the Fourier-based clustering. Thank you for your attention. This is our context, and thank you to René Magritte for his paintings.